on adding integers, and we're going to our next operation, which is subtracting integers. And we learned today in our warm-up that addition and subtraction are inverse operations, or operations that undo each other. The reason that it's important that we know that they are inverse and that they're grouped together is that they share special properties. And one property that we learned in the warm-up is that all subtraction expressions let me move my text box. Is that all subtraction expressions can be rewritten as addition expressions. Now, why is this important to us? Well, that means our steps for subtracting become quite easy because we've already learned how to add. So all we have to simply do, an added step, is to rewrite my subtraction as an addition and then follow the steps I've already learned before. So we're going to start this instantly with writing down our steps for solving. So our first step is, like I mentioned, we rewrite our subtraction expression into an addition expression. Now, how do we do that? So this step has a series of sub-steps, if you will. And what we do to do this is we use the acronym in our class, K, A, C. What does the K stand for? Well, the K stands for keep. And what do we keep? We keep the first integer in our expression as is. What does that mean? We don't touch it. It stays as it is. But then we start messing with some things. So instead of subtracting, we do A, which stands for add. So what we do is we change our subtraction sign to an addition sign. Well, if we change from subtraction to addition, then what do we have to? We have to count for that somewhere else. And we do, and this is where C comes in. So we have keep our first integer, add instead of subtract, and now it's change. And what do we change? We change the second integer to its opposite. What is this essentially saying? It's saying, and this is important, that subtraction is the same thing as adding an opposite. So that's what we do. We change our subtraction to an addition by adding the opposite to the first integer, which we keep as is, and then we have an addition expression. So after we have the addition expression, what do? We identify if integers have the same signs or opposite signs. Now, this should start looking familiar because it's the exact same as addition rules. Well, what if they have the same signs? Same signs is going to be green. Well, remember, if they have the same signs, then your step 3 is to combine or add, because they are the same thing, integers as if they're positive, And then step 4 is the sum sign, match the sum sign. So remember, if you start out positive, your sum's positive. If you start out negative, your sum's negative, right? So that's all that means. Match the sum sign. If we start out negative, our sum should be negative. Oops. If we start out positive, our sum should be positive. So we match the sign. All right, we'll do opposite signs in blue. Now remember, if they're opposite signs, step 3 is to take the absolute value of each sign, or integer, excuse me. And circle the larger one. Why is that important? Because then step 4, you subtract integers as if they're positive. Now remember, I've mentioned this. When we subtract, it's always bigger number minus small. So you know the bigger number is going to be the number that you circled in step 3, the one with the bigger absolute value, because that's going to be bigger if they're both positive. After that, step 4, you match sign with integer that has greater absolute value. Again, the one that you circled in the first place, right? So if you start out with more negatives, guess what? Your answer is going to be negative. You start out with more positives and their opposite signs, guess what? Your answer is going to be positive. All right, that's it. So literally, subtraction is the same as addition with this extra step of KAC. So let's start practicing this. Example 1. My first subtraction expression is going to be this, 3 minus 12. Now I'm going to put a little trick over here on the side, and the trick is always put parentheses around subtraction sign. And what does that do? That helps you really isolate the subtraction from the first integer and the second integer. So what I do is I see the subtraction sign in the middle. I'm going to put parentheses so that I know it's positive 3 minus positive 12. It very clearly visually shows me what I'm subtracting. All right, so what's my first step? Well, my first step is to keep add change. We did it K, A, C. So I'm going to show you how easy this becomes. It was positive 3. It stays positive 3. Instead of subtracting, I add. Now it was positive 12. It becomes negative 12. Again, subtracting is the same as adding the opposite. So 3 minus 12 is the same thing as 3 plus negative 12. All right, now we go on. I look, I see 3 is positive. 12 is negative. What does that mean? That means they are opposite signs. So I instantly go take the absolute value. The absolute value of 3 is 3. The absolute value of negative 12 is 12. Well, that means negative 12 is bigger, right? Okay, so then I do 12 minus 3. Well, what is 12 minus 3? 12 minus 3 is 9. But my answer shouldn't be positive 9. Again, my answer should be negative 9. Why negative? Because I started with more negatives. Negative 12 is a bigger absolute value. That means I'm going to end negative on the number line, or I'm going to have more red integer counters when I add these together. So the answer is negative 9. Negative 9. Let's try another one. Example 2. We have negative 8 minus negative 13. Again, I'm going to try my trick here. Now I see I have parentheses around one integer already, but I'm also going to put them in the front integer so that I really see what I'm working with here. I see negative 8 minus negative 13. So I'm going to KAC. I'm going to keep this. It becomes negative 8. Instead of subtracting, I'm going to add. So that becomes plus. And it was negative 13, so it's going to become positive 13. Again, subtracting is the same thing as adding the opposite. I added negative 13's opposite, 13. All right, now I go into my addition rules. I check. This is negative, this is positive. They're opposite signs. Negative 8 absolute value is 8. 13 absolute value is 13. Which one's bigger? This. That means my answer is going to be positive, right? I have more positives than negatives. Since they are opposite signs, I subtract 13 minus 8. 13 minus 8 is 5. Again, it's going to be positive 5. I'll put it in green because there are more positives when I start out. There's more positives, more green, 13 greens, and only 8 reds. These are how those integer counter models really come in and help us. If you don't know what I'm referencing, you can go to background knowledge. I have some videos there. Let's do one last example, example 3. 5 minus negative 4. Again, I have parentheses around the second integer. I like to put it around the first as well, so I just have a subtraction sign in between. That means I know I'm working with positive 5, subtracting negative 4. I keep my 5, I add instead of subtract, and my negative 4 becomes positive 4. Remember, subtracting is the same thing as adding the opposite. Instead of subtracting negative 4, I'm adding 4. All right, well, this becomes really a simple problem then. I know I have 5 and 4. They're both positive. So what do? I simply combine them. What is 5 plus 4? 5 plus 4 is 9, and it's positive because we started positive. All right, you guys, this is it. Come back to class, and we will practice. Thank you.